We come back to the problem erect the fence from leetcode. Our task here is to draw a convex hole of a bunch of points. We use the brute force algorithm to resolve this problem. It gives us time limit exceeded, because its complexity is O(n) cube. For now, we will going to use the Graham's kernel algorithm to resolve the same problem. We don't need this function. Okay, this function we don't need it. We don't need all the work here too. So for this we just need for the moment the cross product function to compute the cross product, because as we have saw in the previous part, we need to know the rotation of the point of a point to know if we can add it to the upper or to the lower. First, we have to sort the points by the x coordinate using the function, the template function here, the stl function in C++ sort. By default, if the content of the array is a pair, this content will be sorted by the first element here, which is the x coordinate. We need a vector or vectors here to store the lower hole. Same for the upper hole. We run over all the points. In the previous part, we saw if a point is not cannot be added to the upper lower hole, for example here, we keep going seeing the previous point until we find a cross product is a positive cross product. So here we can say while first you have to check if the lower hole contains at minimum 2 points, and the orientation of the two last points, sorry, the rotation of the point P with respect with the two last points, if it is positive, then we delete this point, the last point from the lower hole. Same for the upper hole here. If the cross product here must be negative, if the cross product or the orientation of the point P with respect of the two last point, I repeat this, sorry, if the rotation of the point P with respect of the two last points here, this is the first point, this is the second point, is negative, is not positive, then we add this point P to the lower hole. Same for the upper hole here. If the rotation of the point P with respect of the two last points on the upper hole is positive or null, then add it to the upper hole. Otherwise, keep deleting the last point until we find a cross product negative for the lower hole and positive for the upper hole. We can explain this very quick. Let's say that we have some points here. I don't know, it's not. Let's take this upper hole here. This one, and we want to check if this point can be added to the upper hole or not. As you see here, the cross product. I prefer to draw the hole piece by piece here, like this, and like this. We want to check if this point can be added to the upper hole or not. While the cross product is negative, if the cross product is negative, then we delete the last point. Negative, delete, negative, delete, negative, delete, positive, add it to the upper hole, like this, for example. This is what we do here for the upper hole. While the cross product is negative, the point P with respect of the two last points. I repeat this. This is the two last points. The cross product or the orientation of this point by respect of these points here is negative, so we delete the last point. Then check these 2 points. If the orientation of this point is negative, y is negative with respect of these 2 points, then delete the last point. Negative for these 2 points, delete the last point, etc. until we find a orientation and a positive orientation. This is what we do here in the upper hole, for example. While the cross product is negative, is not positive, no, then delete the last point. If it became positive, add it to the upper hole. Same for the lower hole, but we check if it is positive. If it is positive, we delete it from the last point from the lower hole. Now we have to combine. We have to combine these two, the lower hole and the upper hole. Just add the lower by itself to the hole. Then check for every point in the upper hole here. If this point does not exist on the lower hole, if there is a point in the upper hole that does not exist on the whole hole, then add it to this hole. We're gonna check if the upper hole, if in the hole, if the hole, the entire hole here does not contain the point P from the upper hole, then just add it to the hole. Okay, then we're gonna return it. Let's try it. We have an error here. It's this error. This here and here. This is not the element itself, not the value of the point. This is a pointer, an iterator in C++. So we have to add, to access a pointer, as you know, you have to add star here. Access the element of the pointer. Okay, let's try it again. All declared here, double declaration. Here, what is it here? This one. Yeah. Okay. I think it's correct for the first sample. 1 1 exists, 2 0 exists, 4 2 2 4 3 3. we have to give the right answer here. The order is not important. Let's submit it. I think connection problem here. Submit it again. Okay, as you see, is accepted. This code is accepted to resolve this problem. Erect defense problem number 587 from leetcode. We use the Graham scan algorithm combined with the divide and conquer concept. Let's see quickly the complexity here. The complexity of sort, the sort algorithm and the C++ is O n log n, big O n log n. Here we run over all the points with n is the size of the trees here. O n is amortized O n here because these two y's does not always we do not always run these two loops, so it's amortized. Amortized O n. This function, this loop, sorry, we run over all the upper. Let's say if it have in the worst case n element. Find is O log n is logarithmic because we use the binary search algorithm here. Function find. In total, we have this loop O n log. Sorry. The whole complexity here is O n log n. Okay. Now this is the Graham scan algorithm, guys. I hope it's useful for you. See you later.